Alright, so this video is to help everyone review Unit 1 and 2. Okay, so if you remember, Unit 1 was all about transformations and stuff like that. Unit 2 talked about supplemental angles, complementary angles, transitive properties, and then we talked about different types of reasonings and the P's and the Q's and the different types of statements and stuff like that. So we're gonna review that stuff right now. It's gonna be kind of mixed up a little, but I'm gonna start with, I'm really just winging it here. Okay, so I'm gonna start with the basic stuff. All right. So if you remember, we have supplemental angles. Supplemental angles, okay? Supplemental angles add up to 180 degrees. 180 degrees is supplemental angles. All right, so if you have an angle over here and an angle over here, and you know one angle measure and you're trying to figure out the other angle measure, all you got to do is figure out this. You take this angle measure, subtract it from 180 degrees, and you have the other angle measure. Or if you're given like two variable statements, you like x minus, 12, and then 2x plus 3, like you're given those two things, you know that this plus this equals 180 degrees. Okay, so that is supplementary angles. Okay, supplementary angles. Okay, next you have complementary angles. Complementary angles. Complementary angles. Okay, complementary angles add up to 90 degrees. Okay, so if you have two different angles, like this angle and this angle, and one angle is like, like 30 degrees, and this angle is, I don't know what it is, right? And then you can be like, okay, well, this angle is 90 minus 30, so this angle must be 60 degrees. 60 degrees, okay? But, this might be, you might have two variable statements. So you have like 5x plus 3, and this is like 7x minus 6, right? And you can say this plus this equals 90 degrees, right? So that is how you figure out this kind of stuff. I just made these up. I don't even know if it'll work, right? But this is how you figure this stuff out. Complementary angles, they add up to 360, or they add up to 90 degrees, okay? Then you have congruency. Right? Congruency means that the angle measures are the same. It looks like equals, but it has a little squiggly line over it. Vertical angles are congruent. Okay, so when two lines or line segments come together, like these line segments, the angles next to each other are opposite each other. These are vertical angles, and they are congruent. They share the same measure, right? And this one, these two share the same measure. Okay, those are vertical angles as relative to each other. Okay, they have the same measure. Okay, linear pairs. They are supplementary. So this green angle and this purple angle are linear pairs. This plus this equals 180. This plus this equals 180. Okay, these equal this, and this plus this equals 180. This and this equal each other. Okay, so if you're given like a variable statement like this is x plus 7, and this is 3x minus 9, right? You can say that the x plus 7 equals 3x minus 9, okay? Or if you're given like this is 7x minus 32, right? You can say that's x plus 7 plus 7x minus 32 equals 180. That's how you do those two things together, okay? That is congruency and linear pairs all in two intersecting lines, okay? Then you have angle addition. Angle addition. Okay, say we have an angle, right? And then we have another angle in between here, and this is A, B, and then we have angle C here, and this is angle D, okay? And we know that this angle is, we'll say it's angle, I don't know, we'll say this in general terms, all right? So this is, we know this is angle ADB, angle ADB, all right? So this bigger angle, and it's made up of these two smaller angles, this angle and this angle. All right, so in general terms, you can figure out lots of different things. You might be given this angle, right, and this angle, and you got to figure out the total, right? You might be given the total and one of the angles, and you got to figure out the other angle. And it might be in variable terms. So you might be given like 6x minus 7, and this is 42x plus 5, right? And you have to add these two together to get the whole thing, right? Or maybe you're given the whole thing here, and it's the whole thing is 175 degrees, right? And this is that, right? And then so you just have to be this minus that equals that, right? So you just got to figure out, and you just have to understand these relationships so that you can understand, so you can calculate these angle additions, okay? Angle addition property. Okay, then you have the line segment addition property. Okay, same thing. If you're given a whole line segment, right? You might be given this whole line. This line segment is just a whole thing, right? And maybe it's like a third of this, and you're given A, B, and C, right? And maybe this is a third, and they say that this is like 5x minus 2, and this is a third of that, so the whole thing is 3 times 5x minus 2, right? So the whole length of this thing would be 15x minus 6, right? So that's how you'd figure that thing out. Now, say you had a line A, and B, and then you had point M, which is the midpoint, right? And then they said that, hey, this is 3x minus 5, and this is 2x plus 6. How would you solve for x here? Well, you know, if this is the midpoint, then you know that this line segment and this line segment equal each other, right? Because it's the midpoint. That's what the definition of a midpoint is. AM equals MB, right? So then you can just say, hey, that these two line segments equal each other. The length of these line segments equal each other. Because they equal each other, these two polynomial statements equal each other, set them equal to each other, and solve for B, right? Or solve for X, excuse me, okay? So just remember, you use what you know to figure out what they're asking for. I know it's not in chapter or units 1 and 2, but some general things about transversals. Remember, you have the acute, you have two parallel lines split by a line, right? And then it forms two general angles, an acute, right? An acute angle and an obtuse angle. And it's going to repeat this pattern, right? It's going to repeat this pattern, right? Your obtuse angles are the double ones, and your acute angles are the single ones, right? I'm not going to go over which ones are alternate interior or anything like that. You just need to know the relationships. It's going to be vertical angles here, your obtuse angles here and your obtuse angles here, and you know that these, you have two sets of vertical angles, and these are all equal to each other, and then you have your obtuse angles here, and these are linear pairs. So these mirror each other here. So you should be able to figure out these relationships here, and with numerical values, identify and solve for different numerical values here. Okay, if you might be given, you know, some different things like this, right? Maybe you have lots of different things, and you're given, you know, this is 36 degrees, this is 52 degrees, you know, and you're just given, you're given, this is 40 or 91 degrees, right? And you have to figure out lots of different angles. I mean, this is like 30, this is I don't know, 51 degrees, okay? Well, and you're like, okay, solve all this stuff, right? And maybe, I don't know, I haven't really given myself everything I need to know, but maybe I have, all right? So you have to solve for like a lot of these different angles, right? So I know that this is a vertical angle of this one, so that's 51 degrees. I know this is a vertical angle of that, or not, this is a linear pair. So, you know, as a linear pair, it's going to be 180 minus 51. You know, so that's going to be 180, 51, so it'll be 129, so this will be 129. That's a bad example, because that's a polygon or a quadrilateral. The interior angles of that would be, you know, 360. But here's a, you know, a triangle, so this would be 52 degrees, you know, so that would be 52 plus 51. 52 plus 51 equals 103 minus 180. So that would be 77 degrees, right? Because the interior angles of a triangle equals 180 degrees. So you use all these different rules. So if that's 120, if that's 129, that's 91, right? So all three of these would have to equal 180 degrees. That's 129, that's 191, or that's 91, so 129 plus 91 equals 220. That's not right. Well, so this isn't possible. So 129 plus 91, yeah, this isn't even possible. So anyways, like I said, I just made up some numbers, right? But say, you know, you'd have to take this value and this value, and this would have to equal 180, right? So they're going to give you something like this, and you just have to figure out what is valid and what could actually make sense and what's possible. Okay, so like I said, I just threw down numbers and I made something up. This isn't actually possible, but something like this is possible. Okay. All right. Next, it talks about different transformations. Transformations. Remember, there are 4 types of transformations, right? And it's split into 2 different groups, right? There are isometric, also known as rigid transformations, right? And these are ones where congruence is maintained, right? Congruence is maintained, right? The shapes, everything about the shapes are maintained. The angles are maintained. Distance is maintained. Right? The shapes don't change, right? Orientation changes, but the shapes don't change. So the 3 different types of isometric transformations are reflections, rotations, and translations. Reflections is like when you just reflect it, or it kind of mirrors itself across a line of reflection. A rotation is when it rotates about a point or an axis, and then a translation is when it just like picks up and it moves it, right? That's a translation. The other type of of a transformation is a dilation. Okay, a dilation is when the shape actually grows or shrinks. Grows or shrinks. Grows or shrinks in reference to a scale factor. Okay, and the only thing maintained here are the angle measures. Right, the distances are not. Distances are not. Okay, so that's just a real quick reminder about transformations. Okay, you can review. You might need to review a little bit more of this to answer some of the questions in the assignment, and you can go. Hold on a second. To Unit 4 for all your algebraic transformations of this stuff. If you need a little bit more help with some of the questions. So Unit 4 has some more in-detailed stuff if you need it. Okay? Sorry about that if you needed a little bit more detailed stuff on that one, okay? Unit 4, if you go to Unit 4 and you go to Unit 4 on focus, and you go to the exam assignment, and you'll click on that, and you'll see all the different algebraic expressions and stuff like that. And if you remember, that should help you out a lot with that stuff. Okay. All right. So let's look at. Oh yeah, and then we have.